Hi class. Today's video goes with homework 25, which is the first of 4 homework assignments, all of which deal with factoring. And this one we're going to be focused on the greatest common factor that we can take out of things. So when we talk about factoring, this is sort of the opposite of multiplying. How do we take a polynomial and then figure out what two things we needed to multiply to get that? So when we factored numbers in the first unit of this course, we said 6 is 2 times 3. So 2 and 3 were factors of 6. And this polynomial, x squared plus 5x plus 6, is what we get when we multiply x plus 3 times x plus 2. We can check that. We get x squared plus 2x plus 3x plus 6, which is x squared plus 5x plus 6. So we can say that x plus 3 and x plus 2 are factors of x squared plus 5x plus 6. Just like there were prime numbers like 7, there are polynomials which we can't factor into anything smaller. So like x plus 8 can't be factored, x squared plus 16 can't be factored. So sometimes when you're doing the homework, you might see the choice factor it or mark this if it can't be factored. That should be rare. You shouldn't find that happen a lot of the time. Here is sort of the structure for what you're going to see in the homework. Homework 25 is going to be the greatest common factor. 26 and 27 are similar, like more practice with the same thing. These are polynomials that look like x squared plus or minus something plus or minus something. So maybe something like x squared plus 7x plus 12. And you're trying to break that up into factors. So that would be 26 and 27. And then 28 is going to be special things. It's going to focus a lot on perfect squares. And then altogether, that'll be all the different factoring. So in this first unit, we're just looking for a common factor, something that all the terms have in common that we can pull out in front. And so in this case, I see 3 and I see 18. So I'm going to look at the coefficients, and I know 3 divides 3 and 3 also divides 18. So I'm going to say 3 is part of the greatest common factor. And then in terms of the variables, the greatest thing that I can take out of both is an x squared. I can't take an x cubed out because there aren't 3 x's in the first term. And so this term right here is what's called the GCF, the greatest common factor. And then what you're often asked to do is, once you know that, to figure out what you have to multiply that by to get the original polynomial. So when I do 3x squared times 1, that'll give me 3x squared. I have a subtraction sign there, so I need a subtraction sign here. 18 divided by 3 is 6. So I need a 6 here. That's 18. That's this 18 divided by this 3. And then if there were 3 x's, but 2 of them are out in front, there's 1 left over on the inside. So we'll practice that some more, but you have to look at what's in common and then what's left over once you factor that out. So in this case, I can see that the 4 is divisible by 2 and 14 is divisible by 2. So in each case, I can pull out a 2. And I can see that I have 3 x's there and 2 x's there. So there's only 2 x's that are the common thing. So the GCF is 2x squared. Now to figure out what's left, I'm going to do 4, this 4 divided by 2 is 2, and this 3 x's with 2 of them out in front leaves 1 x left over. You need to be able to do 2x squared times 2x to get 4x cubed. That was a subtraction. This is still a subtraction. 14 divided by 2 is 7. There were 2 x's before. There are 2 x's out in front, so there's no x's left. And again, I can check myself if I want. So this is the answer, but I can check myself by multiplying. 2x squared times 2x is 4x cubed. 2x squared minus 7 is negative 14x squared. And that's what I had to begin with, so I know that the circled is correct. If you have any other questions about GCFs, you can let me know. Note that we're going to keep looking for a GCF. That's going to be our first thing that we do as we keep working in the rest of the lessons. Have a nice day.